Welcome to Solution Kit. Here is now we are going to discuss about mechanical properties of fluids questions. Just now we discuss a easy question. The force of buoyancy is equal to. What is buoyancy? We should first know what is the buoyancy. So we learn about buoyancy. Now if we have a cylinder or a tube, assume a cylinder and take one box and like a wooden block or any ship, we take now as one square box. Okay, now it is in the equilibrium. When body is in equilibrium, the upward force is equal to downward force. Now assume what are the upward forces and downward forces. Here we have F1 and here we have F2. F2 is acting upwards and F1 is acting downwards. The F2 minus F1 is equal to resultant force. So it is now we are going to get that value. What is F2? For example, you take the liquid in this is as density of rho, and in this take as some like this sigma. Okay, now write F1 value. F1 means what? From the height assume H1 and below point as H2. Okay, is it clear? Now F1 is from the height H1, so we can write as M into G, where M we can write as volume into rho. Here what is the rho? I mean density. What is the density here? We should take the density of liquid. Why means we are assuming on the surface. On the surface the force from the block is not x. So we are taking volume into rho into g. Okay. How we can write volume? Area into height. Area into height. Here height is A1 and area is this. Okay, and rho g. And next F2. F2 also mg, but m value is here v is AH1, but here v is AH2, rho g. All are same. F2 minus F1 we get upward force, so A H2 rho g minus A H1 rho g. If we take common, rho A g into H2 minus H1. Here H2 is from upon the surface to here and H1 is upon the surface to the surface of the block. So H2 minus H1 we get H2 minus H1 we get the height of the block. So it is assume height of the block H. Now rho AH G. Okay. Now A into H. What is A into H? Volume of the body. Why? Because we have area of the body into height of the body, so we get volume of the body. Okay, and next here rho. What is rho? Density of liquid, not the density of body. Okay, density of liquid into density of body is not equal to mg, so we should take this as. Now we got upward force. Upward force is equal to Fv. We learn the definition in theoretical part. Now we got rho VB. Now take same diagram. If we take like this, the upward force is not acts by this, so we should take only the value which is inside the liquid. On that only buoyant force acts, not upwards. So we should take only the body which is immersed in the liquid. When the body is immersed, some water displaces for taking the body. So how much displaces, how much the volume of the body is there, that much the water displaces. So volume of the body is equal to water displaced, volume of water displaced. Okay, okay, here we got volume of the body. We can write volume of the body equal to water displaced. Okay, water displaced into rho into G. Volume of this is also water and this is also water. Rho into G, rho into V, we get mg, where m is mass of weight water displaced. So mass of water displaced into G is equal to weight of water displaced. So we get the answer as buoyancy force is equal to weight